All right. Let's go ahead and keep the chat to a minimum so that we're paying attention. Remember, we talked about it this morning in our thing, whole class learning. Pay attention. We're gonna start like a really short project, basically. So we're gonna watch a video just to review a little bit, and then we will go over the instructions, and then I'm just gonna let you guys work, basically. So there's not a whole lot we're gonna do as a class. It's more of you're gonna be doing a small PowerPoint on your own. But I'm gonna share my screen. We're gonna talk a little bit about the instructions, and then we'll watch a quick video. I'll show you guys where some resources are, and we'll get going. So if you're in Google Classroom, I did post another assignment under Science. So if you go to the Science, it's called Adopt an Element Project. There's two things there. There's a Word document that you should only be able to look at. You shouldn't be able to type in it, but it's the instructions for it. And then there's also a Google Slides, which we'll talk about the slides later, so you don't need to start them just yet. But we're going to look at the, what is this called? Instructions first. Let me zoom in a little bit. So it's called Adopt an Element. And we have talked about how an element is basically like one atom has different amounts of electrons and protons and creates an element. So the periodic table of elements is kind of the big thing there. So you have elements like oxygen, hydrogen, iron, bromine. There's all kinds of different elements. So you guys will be adopting an element and kind of making a short presentation on some facts about your element. So we kind of adapted this a little bit to make it more online friendly. So that's why we have a PowerPoint. We had originally to do it in person was make like a cube, like a big box, and all the different sides would be different facts about your element. But we can't really do that. If you want to make the box at home, you're more than welcome to, but I do need you to do the PowerPoint first. So it says you will demonstrate your knowledge of elements and the periodic table by gathering from the textbook, which we don't have. So I provided websites and creating an element baby block, but in this case, it's a PowerPoint to display your research. Each side of your project or each slide will include different information that we talk about below. So you can be creative, you can add colors to your thing. The PowerPoint that we have is just white at this point. So you can change the theme, you can add colors, however you'd like to do it. And it needs to include all the required parts and show what you learned about your element. Says it must be typed, but again, it's online, so it's okay. It will be typed anyway. If you use a picture from the internet of something, make sure you include the source, so the website that you got it from, so that you're not plagiarizing someone's work. You're not doing it with a partner, sorry, that's a little difficult. So each side, the whole cube will be the PowerPoint in this case. There's no cube, so you can ignore the cube part, but side one, which we can call slide one, will be the name of your element. So it must include your name and the name of the element that you choose, which we will choose later. Okay, so that'll be like your title slide. The second slide will be the Bohr model. So yesterday we talked about the way that the atoms look. So your element has an atom that looks a certain way. It has a certain amount of protons, neutrons, and electrons. That's the Bohr model. You're going to need to find a picture of it that has keys and labels to tell us what the protons, neutrons, and electrons are. And you need to make sure that you include the correct energy levels of the protons and all of those things, which we'll talk about when we go to the PowerPoint. Slide 3 is going to have some element properties. So you can list some chemical properties of your element, the physical properties of your element, and it will include at least one picture representing the chemical or the physical property. Okay. Slide 4 is going to be a little bit of a history of the element. So a paragraph, and you're going to write the history. You might want to include who discovered your element, when and where and how it was discovered, and the impact on society. So something like silver. We're going to use silver as an example for this whole thing when we go over an example. So you won't be able to choose silver anyway. But silver, the impact on society, it's used in a ton of things. Necklaces, coins, all kinds of impacts on society. And then we can, if we were doing silver as our element, we could look up who discovered it, where, when, and how, and all of those things. So, and then it wants you to include at least one picture. Slide 5 will be the uses. So again, you're going to write one paragraph to describe how your element is used. So you can talk about one or more of the uses, how it's manufactured. It could be an element that doesn't really occur naturally. So how is it manufactured? Does your element cost something like silver? Silver costs money. What about the impact on society for other things? All kinds of stuff like that. So there's a few things that you could add on there, and then at least one more picture. And then slide 6, our last slide, will have 3 to 5 interesting facts that you found that can't be used anywhere else in your project. Okay? This is just the rubric. Okay? So give me a thumbs up if you're following a little bit so far what we're going to do. Okay, I'm going to show you guys an example, and we're going to go through what the PowerPoint looks like and what's going to go on in the PowerPoint stuff first.
Okay.
But before we do that, we're going to watch, we already watched this video a couple days ago, but we're going to rewatch it just to put fresh in our mind what the periodic table of elements looks like, what kind of elements are on there while we're watching it. Maybe find, besides silver, you're not going to be able to choose silver, but maybe choose an element that you're like, oh, I want to do that one. That one looks like a fun one to research, okay? So be thinking about that while we watch this, not TV, what is it called? Video. Ready? Cool? All right. Here we go. I love brain pop. I'm going to hide this. All right, make sure your mic's off so that it doesn't do like a playback. So here we go.
Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these 3 particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full.
Okay, we're actually going to stop it there because that is not super necessary to remember. So that's just a little bit of an introduction. They only talked about a few of the the elements there. Let's see, I'm going to pull up a periodic table. I have one right here. So this is one example of a periodic table. It's just like a very small drawn one. But these are the elements I'm going to have you choose from. Right now it's just showing their chemical like symbol. These are the first 36 elements that are on the periodic table, and I also have them listed. They're listed right down here. So element 1 is hydrogen, 2 is helium, and it goes all the way down to number 36, which is krypton. So there are 36 elements here. We'll go back to this, and you'll get to choose from this list in a few minutes. But before we go on, does anybody have any questions so far? Doing all right? Okay, I'm going to show you an example. How's that sound?
I'm good.
Okay, I'm going to go show you an example. Oh, wow. Super zoomed in. Hang on. I didn't pull it up. My bad. Okay, so here's an example. So like I said, you're not going to be able to choose silver because we're going to do, it's our example. So you can just copy mine if you got to choose silver. So we're not going to do that one. But this would be like what slide 1 would be. You have the chemical name or the element name, and then here's the person's name who's doing the project, Aaron Greenwood. You can also add some pictures if you'd like to. Notice that when they added this picture, they also put where they got it from, Wikipedia. Okay, so that would be an example of slide 1. Element name plus your name. Slide 2 asks for the Bohr model, which is where the nucleus has a certain amount of protons and neutrons, and then you have all of the electrons surrounding it. And then again, they have the source that they got this from, and it's telling us that there's 61 neutrons, 47 protons, and 47 electrons. If you can't find a picture that tells you how many protons, neutrons, and electrons are, you can always just type it into your Google slide instead. So as long as you find a picture of the model, you're good. Just type in the rest of the information. There's slide number 2. Slide number 3 asks about the physical and chemical properties. So you're going to have to do some Googling around. I have a few websites that you'll be able to use as well. But the physical properties are things along the lines of what it looks like, how heavy it is, what type of temperature it takes to boil or melt, and all of that stuff. So physically, what can it do? The chemical properties are more of what it reacts with. So silver, when it is introduced to oxygen, does not react. So if you're wearing a necklace that's made out of silver, it's not going to suddenly burst into flames because it's touching oxygen, right? So those are like the chemical type of things. It doesn't react with water. However, silver does react with a chemical called hydrogen sulfide, and it causes the silver to tarnish, which means that it kind of turns greenish. So those types of reactions, when it's mixed with other chemicals, what happens? Okay, was that slide 3, I think? Slide 4 is the paragraph that has some history, so you're going to have to, again, do a little bit of research. tell us about your element and write 5 to 7 sentences in your own words. Keep in mind that you can't just go copy and paste from other websites. That's technically plagiarism. It would be stealing other people's work. So you need to make sure you put it into your own words when you write these paragraphs. Okay, so this is just the history of your element with some pictures too. The next slide is its uses. So how is silver used? Again, you want to make sure that you don't just copy and paste stuff. You want to put it into your own words, but you're going to kind of Google around, research what sort of uses does your chemical have. So if you got gold, what sort of uses does that element have? It's worth something, lots of money sometimes. So slide 5, and then slide 6 is just some more fun facts about your element. Things that you can't really fit into the other categories of like physical properties or chemical properties. So just some cool, interesting facts that you find. Okay, so there's an example. I can put this, I think I put it on Schoology, so you guys can look at the example too. How are we doing so far? Still good? Making sense?
Yep.
Okay. Let's look real quick. Yeah, thank you, Charles. I'm aware that you guys are chatting. I can see it. But the more you chat, the less you listen. So let's look at what your guys' slides look like. So when you open it on Google Classroom, it's just a blank, empty slide that gives you directions on each one. So if we're at the first slide, anything that's in black type, you need to leave the formatting the same. So let's say you do get silver, you would just delete it and type in silver. So the formatting would stay the same for you. Okay? And then you would write your name underneath it. And you can go to like the themes and stuff and change the background however you want to make it. As long as it stays appropriate, you're good. Second slide is the model. In black, you need to keep the formatting the same, so that would just stay the same. But the purple stuff you can delete because you need to do what it says in the purple. So the purple says find a Bohr model of your element that shows the protons, neutrons, and electrons, and make sure you have it all labeled. So that's going to be what you do on that slide. Slide 3, again, if it's in black, leave it the same. So slide 3, if you find a chemical property, you would delete the 1 and say, this is my chemical property here. Okay, but we're going to leave that there for now. Purple stuff is just for you to follow these directions, and it tells you what you need to do on this slide. You can delete it at the end. Okay, slide 4 is the same thing. History of the element's going to stay there because it's just the part that you need to keep the formatting the same. The purple stuff tells you what you need to be typing. So writing a history of your element in paragraph form, 5 to 7 sentences, and then a picture. Same thing with slide 5. Uses of the element will stay there, stay the same. The purple stuff is your directions for the slide. And slide 6, again, same thing. Fun and fascinating facts, and the bullet points will stay there. You just need to add your fun and interesting facts. Okay, how are we doing so far? Any questions? Because that's basically it. Okay, cool. Now we need to choose our elements. Let's see. Let me get my okay, here's my class list. Here's what we're gonna do. I'm gonna put up the list. Elijah wants neon. Sounds good. It's all right if you guys double up and do the same ones because we're not gonna be like presenting it. Charles, H2O is not an element. That's a chemical compound. You can either do hydrogen or you can do oxygen. So let me put up the list that you guys can use. Can you guys see this list of all 36?
Yeah. Can I do magnesium?
Yeah, who was that? I can't see you guys. Okay, cool. Okay, Madi, you're good with magnesium. Anybody else?
Krypton.
Okay. Who was it? I can't see you guys.
Olivia.
Olivia, Krypton? Okay.
Helium.
Who was that?
Dallin.
All right. Anybody else?
I'm oxygen.
Oxygen, was that Charles?
Yes.
Okay. I'm just gonna click out of this and I think some of you guys are chatting.
Miss Jones, can I do goal?